It is time to learn about solving probability problems by using combinations. Welcome CTM students to lesson 1210. It can be found on pages 730 to 736. There is no new vocabulary for this lesson, but we are going to be learning how to do this, how to solve probability problems by using combinations. Make sure you're using those extra examples in your book. There are 5 more. We're going to do 3 together here. So let's get right into it. Example 1. Here we go. What is the probability of selecting, we're going back to our old trusty standby, our deck of cards, of selecting 4 picture cards in a row. So boom, 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 boom in a row without replacement. You're not going to put them back. Without replacements. From a standard deck of cards. And I want you to make something like what I'm doing here. So we're going to make a little table. We're going to have the old way over on the left side and the new way on the right side. So we're going to see how you can figure this out in 2 different ways. We're going to have 2 methods for this one. And then from there on out, we're just going to do the new method for the rest of the problems. But over here, we had the AND formula method. AND formula method, that was when 2 or more things are happening in a row. You multiply those things together. We can use that to solve this problem. But we can also use the combination method. So we can use combinations. We just learned about that in the last lesson, combinations, where order doesn't make a difference. And we can use that formula, we can use that idea to solve these probability problems as well. So probability of selecting 4 picture cards. Here are your picture cards. There's 12 of them out of 52, 3 in each suit. And so what's the chance of picking a picture card to begin? The AND formula method, we're just saying the first one times the second one times the third one times the fourth one. We're figuring it out that way. So the first pick, you have a 12 out of 52 chance of getting a picture card. If you don't replace it, without replacement, you're going to have 11 out of 51 next. 11 still are picture cards out of 51 total. Similarly, you've got 10 out of 50 then for the next pick, and finally 9 out of 49 for the last pick. Get out your different color at this point, and let's reduce before we multiply everything together. So I notice 10 and 50, I could reduce that. I could say that's just a 1 and a 5. I could divide both by 10. I also notice that 3 goes into 9 and 51. How can you tell if a number is divisible by 3 or 9? If you add up the digits, this is 5 plus 1 is 6. If 3 goes into that number, 3 goes into 6, it does. So 3 goes into 51. Cool little trick you can use for 3 and 9. So that goes into there. It ends up being 17 times. This ends up being 3. And then I notice I can go top to bottom canceling here, and I can divide both parts by 4. So this would become a 3. This would become a 13. And that's to be expected because 3 out of 13 are picture cards. So that seems to make sense that way as well. Alright, so let's see if I can reduce anything else. 3, 1, and 3 are all prime numbers. 11 is prime, so nothing else can be reduced here unless there's 3 or 11 is divisible into one of these numbers, and no, it doesn't look like it. This is going to be 7 times 7, then the rest of these are prime. So that's what I have left. Let's just write it down. This is a step you can skip later on. You can make sense of what's left though. So this is what's left. This is what I have still remaining that I did not reduce. So let's write that down here though, so we know where this is coming from. Again, a step you could skip later on your classwork, test, whatever. 3 times 11 is 33 times 3 is 99. And then this, that is not an easy thing to do in your head, I don't think so. We'll do that in a calculator. 13 times 17 times 5 times 49. What do you get? You get 54,145. So 54,145. That should be the answer. That is the answer. This, I checked this. I noticed 9 went into here, so did 3 because the sum of the digits is divisible by both 9 and 3. I checked 9 into there, it didn't work. I checked 3 into there, it didn't work. I also checked 11 because that's the other factor up here. It didn't go into there. So nothing works, nothing else is divisible into there. And that should make sense too because we did all the cancellation up here that we possibly could, so I wouldn't expect this one to be able to be reduced anymore. But now the combination method, okay. How is this going to be different? It's still going to give us the same answer because it's still the same problem. We're just using a different method. So think of it like this. What you want over the total. Alright, what do you want to happen going over the total? Same thing as before. So our old standby, our old trusty formula for probability still holds. Want over total. So we have how many cards to choose from for picture cards? You have 12 picture cards to choose from, and of those picture cards you want to select 4 of them. So 12 C4, that'll be 12 choosing 4 of them combination method wise. And then your total is going to be, well, you have 52 total cards to choose from, and the number of ways you can pick 4 cards from 52 cards is 52 C4, 52 choose 4. So off to the side on this one, I want you to write this in a different color so you know later where these came from again. So this was picking 4 picture cards from the 12 in the deck. So that's why we're using 12 choose 4. And then this one down here, where did this come from? This was picking 4 picture cards, or 4 cards from the total number, not the picture cards, but the total number of cards. So this is the number down here of total combinations of 4 cards from the 52. So what we wanted to happen was picking 4 picture cards, that's what this represents, over the total number of ways we could pick 4 cards from the whole 52. From there, now we can use our calculator. For right now, I'm just going to tell you I did these things previously in a calculator. My calculator here, I don't think at least has, let me see. Let's see if it has stats. Does it? Can it do that? No, that's not probability stuff. So I'm not sure. I don't think this has the NCR and NPR. No. So I'm going to tell you I use my scientific calculator, not on the computer earlier, and I just type these things into there. So we're not going to, from here for this lesson, you can use your calculator. You can just plug in the 12C4 into the calculator and get what the number is, rather than doing it the factorial way. So that's 495. Do you still need to know the factorial way? Yes. But this would be 52 choose 4 is 270,725. Now you look at that and you notice hopefully that they both end in 5. If something ends in a 5 or a 0, it's divisible by 5. So let's write that off to the side in a different color. That we can divide this by 5, we can divide this by 5. That leaves us with, whoa, would you look at that, 99 over, if you type that into the calculator, you get 54,145. So do you get the same answer either way? Yes. Which one's easier? I think they're both about the same in this one. But the more things you have to choose from, or if you had to do if you had to choose 20 cards, you would have to write 12 divided by 52, 11, 51. You'd have to go all the way to, and you couldn't actually choose 20 picture cards, but if you had to choose all 12, you'd have to go multiply 12 different numbers times each other, where here you would just write 12 choose 12 over 52 choose 12 and simplify it there. So it kind of depends on the problem, but this is what we're going to use more often in this lesson. This will become simpler and simpler the more complex or the more choices you have to make, the more picks you have to make. So let's move on to the next one, but I want to write down that note that we made. I want to write down the trick that we made, I should say, about seeing if a number is divisible by 3 or 9. That's going to be very handy. I think it's important enough for us to write it down. So a trick for seeing if a number is divisible by 3 or 9. So what is that trick? You remember what I said before? You can add the digits up. So take the sum of the digits. If the sum of the digits is divisible by 3 or 9, then the number itself is as well. Then I think we can just say, then so is the number. So is the number itself. Okay. So we'll use that potentially in our last couple of examples here, but have that written down, know that little trick. Even, they're both even, you can divide by 2. That's simple enough. If they both end in 5 or 0, you can divide by 5. If they sum up the digits and it's divisible by 3 or 9, you can divide by 3 or 9. So let's write this down. I forgot a T in there. A committee, I think that's spelled like that. Let me double check that a second. Yeah, just was having one of those moments where the word just didn't look right to me, but that's right. That's how you spell it. Have you ever had one of those moments? You spell a word and you're like, what is that? Then you look up in the dictionary and it's like, that's exactly how it's supposed to be spelled, and you're just confused and you think the world's about to end. Don't worry, you're not alone. So a committee consisting of 4 people is being randomly selected from a group of 15 teachers and 60 students. Here's what you need to do. Find the probability that the committee will consist of, and we'll have some different parts to this. So we'll break it up into 3 different parts actually. Part A, 4 students. What's the chance of that happening? 4 students from this. So let's see what we have here. We've got probability as what you want over the total. We can still think about it like that. So that's not going away. We're still thinking about probability in that way. How many students do you have to choose from, and how many students do you want? If you're saying 4 students, you want 4 students, but you have 60 students to choose from. So these are the total number of combinations, the total number of possibilities of ways to get 4 students from a group of 60. So what you want, these are the ways what you want can happen. There's that many ways it can happen. What's the total number of ways that this can happen though? We have to take 15 and 60 and add them together to get 75. There's 75 total people to select from. The committee can be all students, it can be all teachers, it can be a combination of students and teachers. So this total would be 75 choose 4. And so let's write a couple things off to the side for that. When you look at this later, it'll make more sense that way. In the different color, let's put down that 60 choose 4. There was 60 students to pick 4 from. And then where did that 75 number come from? So this right here, where is that from? That's just 60 plus 15 equals 75. That's where that number came from. So, calculator time, you type that into a calculator, you end up getting this, 487,635. This is going to be over 1,215,450. So it seems like a pretty decent chance, almost 1/2, and that should seem reasonable, I would say, because there's 60 students, so actually 4/5. 60 out of 75 is 4/5. 4/5 of the people to select from are students, so there's going to be a pretty good chance that they'll all be students, or at least a decent chance that they'll all be students. From there, though, you can reduce this. So let's use our tricks. Let's use our divisible by 2 trick. 5, 3, and 9. Those are the easiest ones to check. And see what we got. So is this divisible by 2? No, they're not even, but 5, yeah, they end in 5 and 0. So let's do that to start. Divide by 5, and divide by 5. Write that in a different color, and let's see what we get. When we're done doing that, we should get 97,527 over 243,090. I used a calculator to check that out. From there, can you divide by anything else? Let's see, they're not even, so not divisible by 2. This one ends in a 7, so not divisible by 5 again. But let's add up the digits, see what we get. So this would be 16, 21, and 23, and 30. So that's divisible by 3 at least, because 3 goes into 30. This one would be 6, 9, and 18. Also divisible by 3, because 3 goes into 18. So let's try that. Let's see what we got. Divide by 3 and divide by 3, and let's see what we're left with. Why don't I get my calculator out? I did do this earlier on calculator, but just to double check and verify some things. So let's do this double checking first. So 487, 635 divided by 5. That is correct. So that's what we got there. How about 1215450 divided by 5? Okay, that works. Let's divide that one by 3. We're left with 81,030. So that would go here. And what else we got? We've got 97,527 divided by 3 is 32,509. 32,509. And from there, I tried all kinds of different numbers. Nothing else worked. And so that is fully simplified. Why do we do this simplification? Well, there's sometimes different ways to do problems, and you might end up getting answers that don't look the same. But as long as you fully simplify things, your answer, no matter what method you use, should look the same. We saw that actually right here. We saw where if I would have left this or multiplied this straight across, then I might have gotten something different, or look different at least, than what I got here. But if I fully simplify this, I end up getting the same thing in the end. So that's why we fully simplify things, so we can compare answers to each other. And that's the answer to that question that seems to be asked sometimes. Why are we doing this? What's the point of this? Why are we simplifying? That's the point of doing that. Now let's say we wanted 4 teachers instead. Much more difficult to pick a group of 4 teachers from here because there's a lot less teachers to choose from. So again, let's write what we want over the total. That's what we're doing. But this time it's going to be 15 choose 4. There's only 15 teachers to make the selection from, but we still want to pick 4 of those 15. And the total still remains the same. You still have 75 total people to choose from, and you want to pick a group of 4 from that group. So this becomes 15 choose 4 is 1,365 over 1 million. This number is the same, 1,215,450. And so if you divide each part by, it looks like you can divide by 5 at least to start. So I did that. I divided by 5, divide by 5. Use a different color for that, please. And we've got 273 over, and this one we already did that work, so same thing, 243,090. And I knew that 3 went into here, so let's check if 3 goes into here. 2 plus 7, 9, plus 3, 12. 3 goes into 12. So yes, it does. 3 goes into 273. So let's divide both parts by 3, and let's see what we have left. This is going to equal 91, and this is still 81,030. So very, very, very small chance of that happening. 91 over this, you have a less than 1% chance of that happening actually. And then how about C? What if we had some combination or some combination of students and teachers? So let's say two students and 2 teachers. Trying to talk too fast. Okay, it's what you want over the total still. How many ways can you select 2 students? Well, you have 60 to choose from. And in this case, you would want to select just a group of 2. The order wouldn't matter. That's why we're using combination. Abby and George would be the same as George and Abby. So 60 choose 2. And we have that and 2 teachers. So when we see that word and with probability, generally you should be thinking multiplying stuff. So we're going to say this is 2 students times the teachers. How many ways are there to do that? Well, there's 15 teachers, and we're picking 2 from that group. The total still remains the same. You still are going to be picking 4 total people from the group of 75. So that number will be exactly the same. 60 choose 2, that's 1770. And 15 choose 5, or 15 choose 2, sorry, is 105. And I would be left with 1, 2, this is still the same as it was before. So 1, 2, 1, 5, 4, 5, 0. Alright, if we multiply these together, let's say I forgot to cancel here. Let's say I did that. I would end up with 185,850. I'm trying to show you different ways to reduce within the context of these problems. We still have this right here. So I noticed that I could do this at least. If you have 2 zeros, that's a divisible by 10 one. We can cross off the zeros. So that's the same thing as saying 18,585 over 121,545. And I noticed looking at those, yes, those are both divisible by 5. If you add up these digits, you actually get 9. This is plus 10, 19, 27 on the top. So 3 goes in there, but so does 9. 9 goes into 27. If you add up these digits, you get 4, 8, 18. So 3 goes into 18, but 9 also goes into 18. And so if 5 goes into both of these, and 9 goes into both of these, cool little trick, you can multiply those together and just do the simplification all at once. I can divide by 5 times 9, or divide by 45 on the top and the bottom. And so if I do that, I am left with 413 over 2,701. That is my final answer. That cannot be reduced anymore. Alright, let's move on to our final example. And time to go flying. We are an airline trying to make a decision on where to fly to next. We're going to open up some new routes for our airline. So an airline, apparently we're called SAS Airline. I don't know what that stands for, but that's our new company. That's why I don't know what it stands for. It's a brand new company. Just kidding. Okay. An airline is given permission to fly 5 new routes of its choice. The airline, that's us. We're in charge here of the airline. The airline is considering 15 new routes. Routes, new routes. 15 new routes. I've heard people say both. 4 in Florida. Hi Florida, how you doing? Have you ever been there? Disney World, much better than Disneyland. Sorry Californians, Disney World is way better. Find the probability that I'm not there yet. 4 in Florida, okay. 5 in Kentucky. Distracted by talking about Disney World. Oh, man. 5 in Kentucky. And 6, here's Kentucky, hello Kentucky. 6 in Virginia. All very nice states, very wonderful states. Had the privilege to visit all of them at some point in my life. Virginia is really beautiful. Appalachian Mountains right there. Appalachian Trail runs right through there. Woo, that is some pretty stuff. Pretty country there. Alright, so find the probability. I'm still not there yet. So if the airline, I keep reading ahead. If the airline, getting distracted, getting sidetracked. If the airline selects 5 new routes at random, so of the 15, selecting 5 routes at random, That sounds like 15 choose 5 to me. Yeah, it does. Yes, it does. You're right. Find, hey, there it is. Find the probability that, all right, we're going to have some different parts for this. Part A, 3 are in Florida, abbreviation for Florida, FL. We are in Florida, and 2 are in Virginia. These are the postal abbreviations, so I'm going to use those. What do we want over the total? Think about it like that again. So want over total. We want 3 in Florida and 2 in Virginia. How many from Florida do we have to choose from? Well, there's only 4 we have to pick from Florida. So 4, choose 3 is our first part. And then we're multiplying that, the and part. So we're going to multiply this. 2 in Virginia. 2 chosen from 6. So 6, choose 2. This is what we want to happen. 3 in Florida. There's the ways Florida can happen. And then 2 in Virginia. Multiply them together. That's the total ways that you could have 3 in Florida and 2 in Virginia over the total number of ways. So 15 choosing 5. This becomes 4 times 15 over 3,003. And then this one will reduce before we multiply. So sometimes that's easier. Most of the time that's easier, in my opinion. Looks like 3 goes into 15, I know, and it also goes into 3,003 because the sum of the digits is 6, and 6 is divisible by 3. So if you divide that by 3, you get 1,001. You divide 15 by 3, you get 5. What are we left with? We're left with 4 times 5 on the top. That's 20 over 1,001. So not a very good chance of that happening. Only 20 ways out of 1,001 ways where that's going to happen. Part B, let's say we have 4 in Kentucky. 4 are in KY for Kentucky, and 1 is in Florida. So what we want over the total on this one becomes, there's 4 in Kentucky. You want to pick 4 in Kentucky from the 5 that we have to choose from. So 5, choose 1 over, this will be our total on the bottom. So we have that over, still going to be 15, choose 5 on the bottom, but 1 in Florida. So this times, we've got 4 in Florida, picking 1 from that. So 4, choose 1. This should have been a 4, sorry, there we go. 5, choose 4, times 4, choose 1. And that becomes 5, choose 4. There's only 5 ways to do that. 4, just picking 1 out of a group of 4. There's only 4 ways to do that. This is still 3,003 on the bottom. This not divisible by 3, not divisible by 3, and that's divisible by 3, but not even, not divisible by 5. So we can't reduce that at all. We have 20 over 3,003 for that one. All right, let's do part C. We're going to do just a couple more parts here, and that'll be it. So 1 is in Florida. 2 are in Kentucky. And 2 are in Virginia. So 3 different things happening here. What we want over the total now becomes, you have 4 from Florida to choose from, and you're picking 1. And then you have Kentucky, you have 5 to choose from, and you're picking 2 from there. And Virginia, you have 6 to choose from, and you're choosing 2 out of those 6. The total remains the same still. So we have 15, choose 5. We have 3,003 on the bottom. This will be 4. 5, choose 2 is 10. 6, choose 2, that's 15. Let's reduce before we simplify. So it looks like 3 goes into both 15 and 3,003. I can change that to 1,001. Do this in a different color, please. We got 5 right there. And then from there, 1,001, there's no common multiples that go into any of these numbers, and 1,001 here. So that is reduced as much as possible. This would be 200. 4 times 10 is 40. 40 times 5 is 200 over 1,001. And then to finish it off, I want to do one where it's at one of those at least versions. So one more. These are the little trick is to remember a certain step. So at least one is in Virginia. So yes, you could figure out, okay, what's the chance of 1 in Virginia, and then the chance of 2 in Virginia, and then the chance of 3 and 4 and all 5 in Virginia. You could do all of those and put them all together, or you could just do 1 minus the chance of none of them being in Virginia. That's going to end up being the same thing. So the probability of at least 1 in Virginia, in VA, is equal to 1 minus the probability that none are in Virginia. Much easier to calculate that than to calculate 1 and 2 and 3 and 4 and 5 and put them all together. So let's do this problem this way instead. So we're going to have 1 minus, well, how many are there to choose from that are not Virginia? You have 6 that are Virginia, and so if we go back here, there's 4 in Florida, 5 in Kentucky. That means you have 9 total to choose from that are not in Virginia, and then from those 9 you want to select 5. So this becomes 9, choose 5, over the total here is still 15, choose 5. And then off to the side here, different color, please write where that came from so you know why that was what it was when you look at this later. So 9 of the 15 are not in Virginia. And I did the work on that earlier. I have, and with all these you might want to just double check me. Again, if you're one of my students, you catch a mistake I make in the video, I'll give you a little extra credit for finding my mistake. That helps me out. I want to make these videos the best they can be. This becomes 126 and this becomes 3003 again. I used my little divide by 3 trick, and I noticed this is divisible by 3, the sum of the digits. Therefore, I can cross that out. That would become 42. If I divide that by 3, this would be 1001 again. So I'm going to have a denominator here of 1001 for this part. That means I would want to write this with the same denominator, 1001. And I know 1001 divided by itself is the same thing as 1. So fraction practice there. We've got to get common denominators first, and then we can combine these together. I've got 959 over 1001. So a very good chance of having at least 1 in Virginia. Almost 100%, not quite though. It's more like 96-ish% for that. So from there, that's it. Go back and review if you need to, and let me know in class if you had any questions. I will see you later.